Nobody can really understand that. You look at how.
All right. Let's go over any questions you may have had on that homework for the square roots before we go over the practice quiz. All right. There was a question on number 10, I believe. Right? So let's look at that one. So this was negative 14 over the square root of 10. All right, so can I reduce that fraction the way it is right now? No. Now, if they were both 14 and 10 under the radical sign, I could. But since just the 10's under the radical sign, I can't, divide them both by 2 and make it 7/5. Okay. Now, since there's a radical in the denominator, I have to rationalize the denominator. Okay? Not allowed to leave it like that. And there's no way to simplify that either. So I'm just going to rationalize by multiplying the top numerator and the bottom denominator by the square root of 10. And anything over itself is 1, so I'm just using that multiplicative identity property. Any times 1 of itself, right? It's going to look different, but I didn't really change it. So then I just multiply negative 14 times the square root of 10, which is that. I can't multiply those two because they're not both under the radical sign. And then I can multiply these two, which is the square root of 100. But we all know the square root of 100 is what? 10. Now look at the 14 and the 10. They're both outside the radical sign, right? Now can I simplify that fraction? Yeah. Now I can divide them both by 2 and make it negative 7 times the square root of 10 over 5. So if you had the negative 14 times the square root of 10 over 10, it's right, but it's not simplified all the way. You miss a point for not making it in simplest radical form. Okay? Any others on those 1 to 12? So a few of you had a few of them blank or had a question mark by them. Any of those you want me to do? We're good? Okay. Well then let's look at the practice quiz. Tomorrow's quiz will look just like this. Just be different numbers. Okay? So number 1 says write an equation in slope-intercept form of the line with a slope of 2/5 and passes through point 5, negative 3. So slope-intercept form, remember, is y equals mx plus b. Right? M represents slope, b is the y-intercept, right? Okay, so what we do is we substitute the point, negative 3 for y, the slope, 2/5, in for m, and the 5 in for the x, so we can solve for b, so we have the y-intercept. So what is 2/5 times 5? Right.
Isn't it 2?
Yeah. The 5's just canceled. Okay, or if you multiply fractions, 2/5 times 5 over 1, that's what 5 is, right? It's 10/5. 2 times 5, 5 times 1, and 10 divided by 5 is 2, right? So however you want to think about it. And then we get b by itself by subtracting the 2 to the other side, and we get negative 5 as b. Okay? So just substituting in and stopping is not enough. I want you to find what b is. and we're still not done. What answer do I want, Caitlin? Yes. I want the equation all the way done in slope-intercept form. So don't forget to finish by writing that equation. Okay? Any questions? All right, number 2. Same type of a problem, but we have to put it in point slope form this time, right? And here's point slope form. Y minus y1 equals m, times the quantity x minus x1. The x1, y1 represents the point that I give you, and m, again, represents the slope. This one, all you had to do was plug in, and you were done, right? So this was easier. So this is y minus, and my y1 is -2, my point. And my slope was 1/3. And then x minus, and the x value of the point was 4. Now what I like to do, that's okay, but when I see minus a negative, I like to make it addition. So, why I keep writing that equal sign? So, y plus 2, 1/3 times quantity x minus 4. That's how we did them for practice, so that's what you can do. If you change it to slope-intercept form, you can, but you don't have to. It's not wrong if you do. Questions on that? So again, just pay attention to the details, minus and negative addition. All right, number 3, we're solving a system of equations for 3, 4, and 5. We're just doing each method we talked about. Okay, so first one is substitution method. So when I do substitution, I like to write them side by side. So that's what I'm going to do. Okay, so the first step in substitution is to get one of the variables isolated, one of the variables alone. Doesn't matter, your choice. Now, looking at those 2 equations, what variable would be the easiest to get alone? X in either one, right? That way you don't have to do any division, so you won't have any fractions showing up when you're doing your substitution. Okay? So, William, which one do you want to do? Do you want to get the left x by itself or the right x by itself?
Good question.
Thanks. Your choice.
The left.
Okay. So we're going to take this positive 2y and subtract it over to get it to the other side. So this left x is -2y plus 2, or if you write 2y or 2 minus 2y, that's okay also. Now, make sure when you substitute, you take that expression, what x equals, and substitute it for x in the other equation. Don't put it in the same one. If you put it in the same equation, you're just going to get everything canceling out. Okay? So make sure you put it in the other equation. So this x becomes -2y plus 2, then minus 2y equals 6. Now I have an equation with one variable, and I'm going to solve for that variable. I'm going to get that y by itself. Okay? So if I combine like terms, what's a -2y and a -2y? -4y. So that's what it looks like now. Now I'm going to move everything to the other side to get y by itself. Move the 2 first, and then I'm going to move the -4. To move the 2 over, I'm going to subtract 2. And to move the -4 over, Since it's negative 4 times y, I'm going to divide now. So I get y equals negative 1. Am I finished solving this system? Mason?
No,
Why not?
because you still have to put the y back in.
Now you got to figure out the x, right? To solve a system, you need to find what x value and what y value works in both equations, right? To make it a true statement. So I'm going to take this negative 1 for y and move it. I always like to go right there, but it doesn't matter which one of those you really put it in. But since I'm looking for x, I'm going to put it in the x equals 1. So I get negative 2 times negative 1, which is positive 2, plus 2. Oh, I'm sorry. Negative 2 plus 2. No, I just said it's positive. I don't know why I was thinking. Negative 2 times negative 1 is positive 2, just like I said, and 2 plus 2 is 4. So 4 negative 1 is the solution to that system. Questions? Okay. Number 4, another system. We're going to use elimination this time. So when we do elimination, we want to make sure our x's and y's and equal signs and our constants are all lined up. So everything's lined up the way it was typed out. You know, sometimes, you know, you get a book or something and it might flip the order, might make it a y plus x on you. You know, so just make sure everything's lined up. Now, in this method, you want to look at the coefficients of the x's and the y's and try to make them the same. All right, if they aren't. But in this problem, the y's already have the same coefficient, right? So I don't have to make the x's the same. But if you did that, it's okay. If you multiply the top by 3 and made it 6x plus 3y equals negative 24, that's not wrong, but you're just doing extra work. You already have a 1 in front of both y's. Okay? So I'm going to eliminate the y. Now look at the sign of the y. So are they the same or different? They're the same. They're both positive. So what do we say? When the signs are the same, do we add or subtract? Subtract, right? S for same, S for subtract. So I'm going to subtract these two equations. So 2x minus 6x is a negative 4x. And 1y minus 1y cancel. They're eliminated. That's why it's called elimination. Negative 8 minus 4 is a negative 12. Now remember, this is negative 8 minus 4. Okay? Not negative 8 plus 4. And then divide both sides by negative 4. And we get x equals 3. Are we finished? No, we're not finished. We have to find both x and y, right? So, Caitlin, which of the two equations do you want to substitute the 3 in? Top or bottom? Okay. Again, it's your choice. So 2 times 3 plus y equals negative 8. We're substituting 3 in for x because that's what we got. So that's 6 plus y. And then we'll subtract 6. So y equals negative 14. So our solution to that system is 3, negative 14. And you can check to make sure it works if you want. But it'll work in both equations. You solve the system. Okay, questions? All right. Number 5, same type of problem, but we're supposed to do it graphically. So let me get a graph up there for you. All right, so one equation is 2x minus 3y equals negative 13. All right, so the way we've been graphing is getting y by itself, right? Solving for y. So I'm going to subtract the 2x and then divide by negative 3. And remember, when you divide by negative 3, it's everything. Not just the 2x, but the 13 as well. Two negatives make it a positive 2/3, and two negatives make it a positive 13/3. All right? So 13/3, this 13 divided by 3 is 4.3, repeat, 4 and 1/3. Okay? That's my y-intercept. I go up 1, 2, 3, 4, and a little bit past. There's 4 1/3. Okay? My slope is 2/3. Rise 2 and run 2 or 3. Okay? So if I go up 1, 2 and over 3, I'm about there. Up 2, over 3. And here's where you got to be accurate. 1, 2, 1, 2, 3. 1, 2, 3. So that you get your straight line. Okay? So use a straight edge. Try to be neat. I know that was kind of a small graph, but we did have a graph there for you. And I can get a straight line here, hopefully. Whoa, why did that happen? Kind of missed, didn't I? Did I go wrong here? How'd that happen? That's more like that, right? Up 2 over 3. This is a little off, I think, my graph. What's off about it? I think my y and x axis are off a little bit. Doesn't it? Look like it's off a little bit. See if I can move this. Let me see if I can fix this a little bit. I don't like that being off. All right. So this y-axis needs to move over a little bit. And this x-axis needs to go down a little bit. It still should work. Did I not go up 2 and over 3? It's still not very good. Oh well. Let's see. My graph paper is kind of bad. We'll see how that works out. All right, the other one is already y by itself. All right, so 7, 1, 2, 3, 4, 5, 6, 7. And I'm going up 2 over 1, right? I guess I'm hitting that spot right there, so it's going to be work out okay. All right, so when I draw that line, I know what I did wrong. What did I do wrong? When I went down 2, what did I do? Only went left how many? 2. I should have went one more. So it was me. It really wasn't so much the graph. So I made the mistake. Even when I tried to fix it, will look a little better. Let me see if I can fix it. That bothers me being wrong here. That look better to you guys? We still end up at about the same spot, right? So, my answer is where? Where they meet or intersect, right? And that point there, which is what for the x? Negative 2. And what for the y? Positive 3. Okay. So when you do number 5 tomorrow, get y by itself first. If it's a fraction like that, you can still do it. Just try to be as accurate as possible. Okay. If you have your graphing calculator, and you do 13 divided by 3, it'll tell you that's 4.3 repeat. 0.3 is a little bit past 4, right? So you know where to put it. Any questions? All right, some of you, when I looked at them this morning, struggled with that problem. So make sure you draw both graphs, both lines, on that graph paper there. Be neat and tell me the point of intersection. Number 6, some radicals. So simplifying radicals. So we have to do a factor tree. We're putting simplest radical form. I don't want you to put it in the calculator. And tell me it's 17.32. All right, that's not what I'm looking for. Put it in simplest radical form. All right, so that's when we were doing the factor tree. I'm going to do 3 times 100 and stop. Why am I stopping? No. Right, I know 100 is a perfect square, right? So I'm going to pull the 10 out because the square of 100 is 10. And the 3 stays underneath in the radicand. So that's simplest radical form. Okay? If you kept going, okay? I don't know, 2 times 50, 2 times 25. Doesn't matter how you do your factor tree, you'll still end up with the same thing. If you go all the way down in the prime factorization, you're looking for what? Anybody? Looking for groups of 2. Looking for pairs, right? So I have a pair of 5s. I have a pair of 2s. What do I do with those pairs? I multiply them together and move it out front, right? So if I take a 2 and a 5 out and multiply them, what do I get? 10. What's left? The 3. So you're going to get the same thing. Okay? If you don't see that there's a perfect square in there. All right? Any questions? All right. Number 7, we have a fraction under the radical side. Can I reduce that fraction? Yeah. What number goes into both of those? 2, right? So if you divide the top and the bottom by 2, you get the square root of 36 over 49. That's a nice fraction if I'm looking at radicals. Why? They're both perfect squares, aren't they? So here's where some of you make a mistake. You guys know the square root of 36 is what? 6. And you know the square root of 49 is 7. The radical sign is gone. Some of you kept the radical sign in there. If it's a perfect square, that radical sign is gone. No, nothing left. No left over. Okay? So don't put square root of 6/7. It's just 6/7. The last one, we got 10/3. Can I reduce that fraction? There's nothing that goes into both of those, right? So remember, when that happens, you think about it like this, you have to rationalize the denominator. You can't have that radical 3 in the bottom. So we're going to multiply the top and the bottom by that radical 3. And radical 10 times radical 3 is radical 30. And what's radical 3 times radical 3? Well, 9's a perfect square, right? So what's square root of 9? 3. And you're finished. That's the simplest radical form. Okay? Making sense? Any questions? Okay. Good job. That's all I got.
Couldn't get it out because I was wanting to say nobody put the cards away.